logarithmic functions. The voltage gain in decibels is given by the following formula. It's just 20 common logarithm e sub 0 over e sub I, where e sub 0 is the, actually it's e sub O. E sub O is the output voltage and E sub I is the input voltage. The Richter scale, named after Burton Richter, is R is equal to log A. A is the amplitude and P is the period. So let's do some examples. Oh, wait. C is equal to M times the quantity 1 minus e to the minus kt, where C is the level that you need to charge the battery, M is the maximum charge of the battery, and K is some constant greater than 0, and T is some time. Isothermal expansion. E is equal to RT ln V sub F over V sub I.
Can you go back to the charging batteries one real quick?
Repeat? I couldn't understand.
Can you show the equation for the previous one? I didn't copy it.
Sure. Charging battery?
Yeah.
Okay. Yes, so C is equal to M, the maximum charge, times the quantity 1 minus e to the minus k, a charging constant, times t, the amount of time it takes you to charge.
Thank you.
Isothermal expansion. E, the required energy to increase the volume of 1 mole from V sub initial to the volume V sub F, the final volume. R, where R is a constant, the universal gas constant. T, where T is and we're assuming that the temperature here is being held constant. Ln V sub F, which is the final volume, divided by V sub I, the initial volume. Universal gas constant is approximately 8.314 joules per mole per degree Kelvin. So I guess this should be in degree Kelvin. Everything works out nice. Okay. So let's do some examples on page 455. Use a calculator to solve each problem. The gain of an amplifier. Find the decibel gain of an amplifier whose input voltage is 0.71 volt and whose output voltage is 20 volt. Okay, so let's do that. So the input is 0.71 volts. The output is 20 volts. And I want to find the decibel gain. Really, I always do, is it dB? Isn't it dB? I don't know. I guess it is dB. Okay. Okay, so the decibel gain, not that it matters, is going to be 20. And maybe I'll write it down here. 20 log 20 over 0.71. Okay, so let's plug that into our calculator. Actually, let me just move this down slightly. And so if I plug that into a calculator, I get 28.99543294 decibels. They don't tell me how many decimal places, so I'll just leave it like that. So approximately 29 decibels. Please be sure you use the common logarithm in this case. 15. Okay, let's go back. It disappeared for a second. Okay, so 15. Earthquakes. An earthquake with a period of 1/4 seconds has an amplitude of 2,500 micrometers. Find its measure on the Richter scale. So the period is 1/4 of a second, and the amplitude is 2,500 micrometers. So R, the Richter scale, is equal to log of 2,500 divided by 1/4. So this is the log of 4 times that, 100, 10,000. And so this is an earthquake of magnitude 4 on the Richter scale. Okay. And that finishes off section 4.4. Let me go on to section 4.5.